Before we start doing our ionic bonds worksheet, you're going to want to make sure that in class the other day when we added these notes to the top of our periodic table groups, when we said that group 1 has 1 valence electron, and that means it makes a +1 ion. Group 2 has 2 valence electrons, it makes a 2+ ion. All the way over here to group 17 has 7 valence electrons and it makes a 1- ion. You're going to want to make sure that you have all of those notes on your periodic table before we start. So if you need to, take a second, pause this video, and add those notes in. That's going to make your life much easier when we start working on ionic bonding. And don't forget, you can have all this information on your periodic table, and you can use it on our bonding quiz that we'll have in about a week or so. All right, now that you have that, let's get started on our worksheet. So the top part of the worksheet here, it's giving us an element and then asking us to fill out all this information about it. The first element that it wants us to look at is lithium. Lithium is right here, it's atomic number 3. First thing it's asking us for is the symbol for lithium. The symbol for lithium is Li, and we're going to make sure that we are putting a capital letter at the start of all of our symbols and then a lowercase letter. It is in group 1. If I look at lithium and go up to the top of the column, I see there that it's group 1. And hopefully we have our notes that tell us that group 1 has 1 valence electron. Now, if lithium has 1 valence electron, 1 electron in its outside orbital, and it's going to bond with another one, we need to figure out if it is more likely to gain an electron or lose an electron. If it has 1 valence electron and it gives up that 1 electron, it's going to have a full outer orbital, and that's going to be much easier for it than to gain 7 electrons. So it is more likely to lose an electron, and that is because it is a cation. It is on the left side of our periodic table. It's a metal, it has a positive charge, it's a cation. It's charge that it has because if it gives up that 1 valence electron, it's going to lose 1 negative charge, and it's going to end up with a 1+ ion charge. If we switch over to the other side of our periodic table here, I have iodine over at number 53. So right here in blue, iodine's symbol is a capital I. I always, when we're doing chemistry, put a top and a bottom on my capital I just so that there's no confusion. If I go up to the top of this column here, iodine is in group 17. If it is in group 17, that means it has 7 valence electrons. If it has 7, it only needs to gain 1 more, and that's going to be a lot easier than giving up those 7. So it's more likely to gain 1 electron. That means that it is an anion. It is a nonmetal on the right side of our periodic table, and it has a negative charge, and because it only needs to gain 1, it's going to end up with a 1 negative charge. Sulfur is right here at number 16. Sulfur symbol is a capital S. If I look to the top of my column, sulfur is in group 16. If it's in group 16, we have on our periodic table, that means it has 6 valence electrons. If it has 6 valence electrons, it is going to be much easier to get to a full orbital to gain, and it's going to gain 2 electrons, which means it's going to end up with a 2- charge. And if it's gaining electrons, if it's going to be a negatively charged ion, that is an anion. Calcium's over here at number 20. So calcium, symbol is Ca. If I look to the top of my column, calcium is in group 2. Group 2 has 2 valence electrons. If it has those 2 extra electrons, it is much more likely to lose them than to gain 6. If it's losing electrons, that is a cation, and it's giving me a positive ion, and because it's losing 2, it's going to be a 2+ charge for an ion. And then back over to the right side here, nitrogen is atomic number 7. Nitrogen's symbol is capital N. It is in group 15 with 5 valence electrons. 5 valence electrons means it can just gain 3 to get to a full orbital, and it's going to end up with a 3 minus charge when it gains those 3 electrons, and because it's gaining electrons, it's going to be an anion. For the next part, we're just looking for the element on our periodic table and figuring out what its charge is. And like I said before, you should have this information on your periodic table, and this should be super quick and easy. Sodium is number 11. Sodium is in group 1. It is a 1 plus ion. Phosphorus is number 15. Phosphorus is in group 15. It is a 3 minus ion. Chlorine is in number 17. It's in group 17. It's a 1 minus ion. Barium is over here at 56. If I go to the top of my table, it is in group 2 and it's a 2 plus ion. Fluorine's number 9. Back here on the right hand side in group 17, that's a 1 minus ion. Neon is a noble gas in group 18. Neon and the rest of the noble gases have a full orbital. They're not going to want to hang out with anybody else. They're not going to bond ionically. They're not going to have a positive or negative charge. They are just going to have a neutral charge. Hydrogen, up here in the tippy top left corner, hydrogen has a 1 plus charge. Magnesium is 12 right here in blue, in group 2, so it has a 2 plus charge. Bromine is over here at number 35. It's in group 17, so it has a 1 minus charge. Aluminum is number 13. Here in gray, it's in group 13. It has a 3 plus charge. Boron is right there above it. Number 5 is also in group 13 with a 3 plus charge. Potassium is number 19. Over here in group 1, so it has a 1 plus charge. Nitrogen is number 7. It's in group 15 with a 3 minus charge. Oxygen, right over here in the same area, is in group 16 with a 2 minus charge. And selenium is just here, number 34, underneath oxygen, also in group 16 and also with a 2 minus charge. So the reason we had you practice finding just those charges is because you need to know those charges to have those elements ionically bond. So for this bottom part here, 21 through 30, the first step you're going to be doing for all of these is to look up the element on the periodic table and find its charge. I'm going to zoom out a little bit so that I don't have to keep scrolling back and forth on my periodic table. Make it a little bit quicker to get through this. All right, calcium is here in group 2. It has a 2 plus charge. Do not try to do this in your head. You're just learning. Write it down. Show your work. Oxygen is in group 16. It has a 2 minus charge. If I have a 2 plus and a 2 minus, those two are going to easily cancel each other out, so I don't need to add any subscripts, and I just have CaO for calcium oxide. Lithium is in group 1. It has a 1 plus charge. Bromine is over there, number 35. It's in group 17, so it has a 1 minus charge. Again, +1, -1, cancel each other out. I don't have to worry about any subscripts. I have lithium bromide. Aluminum is atomic number 13. It's in group 13 with a 3 plus charge. Fluorine is number 9 in group 17, and it has a 1 minus charge. All right, 3 plus and 1 minus. Those don't cancel each other out. I'm going to have to end up with more of something. If fluorine has my lesser charge there, if that's only a 1, I'm going to need 3 fluorines to balance out my 1 aluminum. So I'm going to have Al with no subscript, and then F3, so aluminum fluoride. Potassium's in group 1. It has a 1 plus charge. Sulfur is in group 16. It has a 2 minus charge. If I had a +1 and a -2, I need to add more of something. My potassium has the smaller number for its charge. I'm going to need 2 potassiums to balance out my 1 sulfur. So I'm going to have K2S, and that's going to be potassium sulfide. Barium I have is number 56. That's in group 2. It has a 2+ charge. Iodine's over on my other side of the periodic table at 53 in group 17. That has a 1- charge. If I have a 1- charge on my iodine, I'm going to need 2 of those to cancel out my barium. So I'm going to end up with BaI2. All right, let's look at the other column here. Aluminum is number 13 in group 13 with a 3+ charge. Oxygen is in group 16 with a 2- charge. So you might remember from when we talked about these ones the other day that a lot of them are really simple. If you're trying to balance out a 1 and a 2 or a 1 and a 3, that can, that math is easier for some people. But some people look at this a +3 and a -2 charge and get a little bit overwhelmed because they can't figure out what they both go into easily. Remember, you're trying to find the least common multiple. So the least common multiple of 3 and 2 would be 6. So to get that Al with a +3 charge to 6, I'm going to need 2 of them. And oxygen has a 2- charge. To get that to 6, I'm going to need 3 of them. If the least common multiple method confuses you, you can always do the cross and drop. So I have Al with a 3+, oxygen with a 2-. I rewrite my elements. The 3 from my aluminum is going to end up over here with my oxygen. My 2 from my oxygen is going to end up over here with my aluminum. So I have Al2O3. But like I said in the other video, if you understand the least common multiple method, that's really the better way to try to think about this. For number 27, I have, and I'm going to double check this so I don't get this one wrong, but yeah, strontium is number 38 here, strontium, sorry, and it has a 2+ charge as an ion. Nitrogen is back over here on the right hand side. Nitrogen is in group 15, so it has a 3- charge. And look, I got that 2 and 3 again. I'm going to try to go to 6. I'm just going to swap the numbers. So I have Sr3N2, strontium nitride. Helium has a +1 charge. Phosphorus has a 3- charge. Oops. That means that I need 3 hydrogens to balance out my 1 phosphorus. I have H3P. Boron has a 3+ charge. Chlorine is in group 17 with a 1- charge. Means I need 3 chlorines to balance it out. So I'm going to have BCl3. And then my last one on this page is cesium. Cesium's in group 1 with a +1 charge. Sulfur is in group 16 with a 2- charge. I need 2 cesiums to balance out my 1 sulfur. So I have C(s)(2). All right, I'm going to do the back page on a separate video so you can find that one next.